This is video 2.1.2. In this video, your goal is to perform basic operations with complex numbers and to use them to solve quadratic equations. So we're going to look at quadratic equations that have complex solutions as well as continue our understanding of the operations. So let's take a look here. So this first set of operations we're going to do is talking about simplifying square roots that are negative, because this is going to be important to solving quadratics. The first important property that you need to know is what you see here, that the square root of negative b is equal to I times the square root of b. Because of course all we're going to do is take it and separate it as negative 1 times b, and then we separate further. So since this represents I, that is why these two are equivalent. So that's an important property to know. This is going to affect a lot of things. We're going to see it in example number 1 especially. So we see the temptation right now to just quickly combine these square roots and make them all 1. Okay, this is wrong, so do not do this. Okay, but let's take a look at what result this gives us. We get the square root of 100, which is equal to 10. Once again, like I said, this is wrong, and it's because of how we need to work with square roots and with the imaginary number. The proper way to do this is to think of the square root of negative 25 in the way of this property here. So we're going to separate this into I square root of 25. And we're going to do the same thing with the square root of negative 4. It's really just I square root of 4. And if this is all multiplied here. So it looks like we have I squared times 5 times 2, which is just 10I squared. Now remember, we learned I squared is a number. It's negative 1. So 10 times I squared is 10 times negative 1, which is equal to negative 10. So that, of course, is a different solution than what we got using our former knowledge of radicals and how to simplify them. This does not work. Now remember, these imaginary numbers, we don't know many uses of them right now, but there are uses of them in real-life engineering and different science-like problems. So it's important we understand how to perform operations in case we need to use them in the future. And this is the proper way to do this. So first we want to take the negative out by replacing it with I, and then we perform the operations like we already know how. So we're going to show you that with b, because b is similar to if I was solving a quadratic. So let's take a look at b here. Negative 25 plus the square root of negative 50 all over 15. So first I'm going to start with taking out I and writing this as I square root of 50 all over 15. Okay. Remember, with proper form and standard form of complex numbers, we want to separate things. So I'm going to rewrite this as negative 25 over 15 plus I times the square root of 50 over 15. So I can start thinking about how to simplify. When you simplify radicals, remember you're looking for perfect squares. So the square root of 50 can be written as square root of 25 times the square root of 2. I like 25 times 2 because 25 is a perfect square, so I'm going to change that to 5 square roots of 2. So square root of 50 is the same as 5 square roots of 22. It's 5 square roots of 2. So I'm going to replace this with 5 square roots of 2 over 15. And of course I'm going to simplify the other fraction as well and make this negative 5 thirds. And I got that by dividing top and bottom by 5. So I'm almost fully simplified here. My first fraction is simplified. My second fraction contains I, and it can be simplified a little bit further. I can cancel a 5 from the 15 and make this square root of 2 on top over 3 on bottom. So this is the fully simplified complex solution to this original equation, this original expression. So this is the proper standard way to write this complex solution to that expression. So this expression, notice it kind of looks similar to quadratic formula, and that is where we're taking next in the final example of this video. So the next example here, we're going to take a look at how to solve this quadratic. This quadratic First of all, when we solve quadratics, we want to remember we could factor, like you were doing with your trig functions not too long ago. But what's important here is, I'm going to jump to the ending point, is that we can't factor it. We're going to use quadratic equation to find the complex roots. So remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So it looks like my a is 2, my b is -5, and my c is 9. So I'm going to plug into my formula. The opposite of -5 plus or minus the square root of -5 squared minus 4 times a times c, all over 2 times a. Okay, so let's see, simplify this out. I'm going to have 5 plus or minus the square root of 25 minus 4 times 2 times 9 is 72, all over 4. 5 plus minus the square root of, and of course the answer is -47, all over 4. So now I start to see the problem. The solutions are not going to be real numbers, they're going to be imaginary numbers that we're going to write in a complex, it's actually complex numbers that we're going to write out for the solutions. So I'm going to keep it as plus or minus, so 5 plus or minus I square roots of 47, just like we learned in the previous examples. I'm also going to separate these and make them both over 4. 47 is a prime number, so that can't be simplified any further. So this is my solution set. The two solutions are complex conjugates because the first solution is 5 fourths plus I square roots of 47 over 4. And the other solution is 5 fourths minus I square roots square root of 47 over 4. These are your two solutions. They're complex conjugates, remember, because one is plus, one is minus. You learned about that in the first video of this section. So these are the two complex solutions to this quadratic equation. We'll talk more and remind more about why solutions to quadratic equations are so important and how they help us graph and solve other problems. So take a look at the checkpoints for this examples. Use the video to help you understand and remember how to do this, but do your best to simplify and solve these different problems and bring your questions into class.